Let's start with our last talk of today. This last talk will be taking about Vincent Lefebvre du Prey, of the company ITAKA from Italy, and talk is entitled Changing Crop Production Systems. So please, Vincent, the floor is yours.
You are muted, Vincent. You are muted. Your microphone.
Okay. Is the screen okay? Can you see your presentation?
Yeah, sure.
Okay. Thank you very much for having me on today or tonight. So sorry for the delay in reaching the platform. We had a few changes in program. I'm sorry about that. I would like, looking at the program, I'd like to be a little bit in a different tone or different approach, in the sense that I'm not looking at, I'm not talking about scientific elements, but I would like to talk about the changes that we see in the crop production systems and the fact that they are strongly driven. The changes are driven by Europe and by by political desire, let's put it that way. And I could use a subtitle from there, is that would be something around what are the future needs from farmers in terms of DSS. What kind of support will they need tomorrow if we continue changing the production systems? So I'm going to talk a little bit about what we're doing as a company, ITAKA, and how we see some of these things, and what we see as being necessary to help the farmer in the future in deciding in a direction that we would like Europe to go, and in the direction we would like agriculture to go. And that is, if I can, yes, okay. Most of the change that goes around the elements that we've been talking so much about for the past 2 years, okay? Sustainable farming, that's a key. Farmer will do something and change if it's economically interesting for him. Consumers, we know what is being said and what is being required in terms of consumer protection and the environment. Again, we have very strong policies and very strong determination to proceed in the direction of a protection of the environment. We need new solutions, and we need new solutions related to the soil and to the plant, soil and plant health, and this is where we're trying to aim. The challenges are known in terms of legislation, in terms of AI, in terms of price on price for the commodities, soils, and production cost. We also look at opportunities because from difficulties we know that opportunities will come out or can come out, and we see market demand, and that's mostly on organic products and various new approach to production which provide the farmer with a higher income. Let's say he gets a better price, to make it simple. Operator safety has become a very important aspect of what people are looking for, and obviously the farm value. It's an important fact. At the end of the day, though, what the farmer is looking at, is organic farming, yes, but what do we have, and what products or what solutions can we provide for him to do organic farming? And that is in order to make a calculation on sustainability. It's impossible that somebody is going to switch to organic farming without making a reasonable calculation of what is he going to get out, or is it sustainable? Another issue is a lot of products have disappeared, and I'm talking mostly about plant protection product, and we need solutions, and we need to provide the people with various options in order to substitute those products, and in order to reduce residues, where the driving force today is the supermarkets, and they are dictating residue policies. And that has to fit into what we know, and that's the global policy, which is a carbon footprint, which is biodiversity, which is climate change. So from there, and in contact with farmers, and having to provide farmers with policies and strategies and solutions, mostly, we look at what is in the end of a farmer when he starts a season, and we look at the plant, but mostly we look at threats, because this is the first issue that comes up. Not so much if it's pot tomato or if it's wheat, but what's the threat? What's the disease? What's the insect? What's the problem? What's the issue? And we recognize some of the elements that we see today in most of the DSS programs, but we also see quite a few elements where we don't have an approach today. How do we assess resistance? How do we assess biodiversity? How do we look at environment as a farming element, not just as a bucolic expression of going onto a farm or in the nature? So we look at our, let's say, our analysis is to look at the plant health, and plant health for us is a question which is mostly agronomical, in the sense that we can act on agronomy and we can act on soil health. And this is why we're working quite a lot about a concept of healthy plants in healthy soils. First step of soil health is organic matter, is soil vitality, and is nutrition. If we don't have this, we have no soil health. We have a soil with difficulties, and therefore issues with growing anything on that soil. Step two is what we can provide around this. Once we have organic matter, and once we have soil vitality, and therefore nutrition, when it has regeneration, if the soil is in very poor condition or is containing so many pathogens that we have a initial problem by bringing any crop on it, we look at all activities around prevention, and then it's related to soil vitality, because we're looking at most of the disease, soil disease, seed-borne disease and soil disease, and then the resistance and resilience from the plant, and the biostimulation part of it. And we define how do we regenerate soil, and how do we provide a vitality, which today most of the time we call it soil health, but let's stick to vitality also today. Regeneration is an aspect, soil vitality, and it's well defined today, what we call the vitality, the carbon, humic acid, etc. So we have a clear idea of what we need to grow plants. And then we look at prevention, which is looking at soil mostly related to antagonism and root stimulation. Plant health and resistance is basically the foliar part of it. And again, here, there are quite a lot of significant amount of natural solutions which can be integrated. As I mentioned above before, those are solutions to integrate into what the farmer is doing today. And therefore, it is feasible to integrate non-chemical solutions or natural solutions in any program. And that's a fact. What do we use? We use microorganisms first, and we, as ITAKA, we specialized in microorganisms. And today we're developing a lot of research and isolation of microorganisms and looking at territory. We're looking at various elements of how to use microorganisms in the future. But it's not just the microorganisms, it's also the compositions, it's also the formulations, because they are living materials. So we need to develop technologies on that. Same for natural extract and minerals. Those are the basic ingredients for natural solutions, independently from who produces them. Another step is, when we look at natural solution, is all the work and the support that needs to be created. The research and development, for example, we have a research facility now, and we have a lab just to work on microorganisms, plus we have projects with various institutes and universities in order to optimize the work. The next step is adapt solution to the field. So the technical aspects, the results of using the product, and acceptability to the farmers. So is it feasible to apply that product on a farm or in a field? So that's important. And then obviously presentation to the industry or to the food chain, food distribution in general. Quality and control, this is always and remains an issue, for the good reason that we have, sorry, I'm trying to move that away. We have to guarantee our products and the ingredients, and we have to have traceability certification, and they require normally traceability, for the good reason that the legislation doesn't guarantee our product. There is no legislation in Europe that can guarantee the content of a natural product, as opposed to a plant protection product. It would be a procedure and a guarantee on what it contains and what it does, which doesn't exist for natural products. So this is an effort on our side, which is obviously linked to all sorts of certification that we find in Europe, in order to give credibility to the products. And obviously, the last part is the field support, because farmers need to know about the technology and needs to know about the fact that there are solutions. So, in few words, we can present, and we do present, the change to people who are interested, people who are in need of. Okay, and that's a very important point, and this is the major point and the major issue at the same time, because the fact of proposing program, analyzing data, looking at the farm, making sure that products are tested. I mean, okay, this is fine. Guarantee the content, etc. Follow up in the field. This is fine. Today, the issue is people who would like to change. So people have people are interested because the pressure is today on residue, pressure is on organic, pressure is on changing. So they are interested and they would like to know what's going on, and they would like to know if they can include new solutions in their programs. So we present various solutions. We present various results, and we look at microorganisms and activity, PGPR effect, etc., etc. So this is perfect. We looked at basic substance. Again, this is very interesting. This is beautiful, and we should be doing very well. The issue is, how does the farmer move from interest to decision? We have a lot of interest. How do we go to the decision? And what does it mean? And what do we need to get to a decision situation? We know the objective is 30% organic farming in Europe. Today, we're probably around 8, 10. And it's not growing extremely fast. It is growing, but it's not growing extremely fast. How do we scale up? And what are the tools that we could use to scale up what we know, is being done today, and how it's being done? How the farmer decides, and how can we help the decision? And again, we now back to, are there tools that can help the farmers to decide? And again, that has been discussed today, presented, and there are lots of solutions, lots of elements. But once we change system and once we go to something different, what tools do we have? And are they adequate to respond to the farmer's demand, actually to move the farmer to interest, from interest to decision? Now, one of the big issue we've touched, going into the direction that and why I took a bit of time to present a little bit the situation, is the soil plant environment issue, or at least what we would call a continuum, which is the link between these, and how much effort and how much knowledge do we have of that, and how much knowledge can we transmit on that, and what kind of system can be developed in order to help the farmer to understand better his own situation and understand better how to move to natural systems. I put a few elements on the table just to give an idea, but it's more to give ideas than anything else. Today, we know there is a lot of information on scientific information, which is mostly research and lab and elements on soil, on microorganisms, on fertility. We have quite a lot of information. There are quite a lot of projects on that, local, global, European, and so a lot of information exists, and this is interesting. We also figure out from our experience that the local conditions influence the results. So we have here a limitation, which is, in order to scale up any form of information, we need to understand better the local conditions, because it may vary from one place to another one, and some situations may not be, we may not obtain the results we would like. At the same time, in many situations, the officials are not completely involved into moving into the direction of natural solutions. They still or looking at or trying to understand better, but they're not seeing today as being the force to promote the change. In terms of communication, there is a lot of communication on biodiversity, residue, global impact. On one side, the seed companies have been communicating a lot on genetic resistance, and obviously Europe is communicating on active ingredient cancellation. So that is very strong and a lot of communication in that sense. At the same time, as we can't, I mean, that we have limited global experience because of the influence of local conditions I mentioned first. We have a difficulty to communicate globally because conditions may vary from one place to the other, and therefore we may not be certain to have the same results. Also, there is competition between conventional and natural because the conventional has to produce. Basically, this is the normal way to produce today, and we have to produce because that is the economical system that we're in. At the same time, we also have an issue with the legislation because on natural products, we have no clear legislation, and that's not new, and that probably will remain for some time. Hopefully, we'll see some changes from next year onward. Target the communication, where the communication goes. Today, we see the food distribution is the one which is pulling the most, and they have directly or indirectly dedicated technical teams. If you look at the amount of energy people like Lidl or Sainsbury put around on food quality analysis, residue, etc., it's enormous. It is enormous, and they have a dedication. They are dedicated to that. If we look at technicians or consultant co-ops or groups, etc., we don't always have the same strength to change or willingness to go above or ahead of what we're doing today. Very often they remain into the fact that well, we can use two residues, so let's use two residues, and then we'll see what we do. And that is also certainly a limitation on what we can achieve today. Trying to be a little bit more concrete on the needs, what farmer would need to go into the decision of, I mean, on the direction of decision support. We know pretty well soil characterization, and we start with soil health. Characterization of things that we know pretty well today. Nutrition, we know quite well. We're still developing tools to understand better the situation and the monitoring of the nutrition. We start seeing sensors around, and we have a better idea over time, at least during the growing period, of what's going on in the field. It is still fairly recent, and it's still it's something that is taking place now. Where we lack significant information is on soil health directly, which is the activity, biodiversity, the microbiota or microbiome. How do we define it? What is supposed to be a balanced soil in terms of microbiome? We'll talk a lot about, a lot of discussion about diversity, but today for a farmer, it's not very obvious what it means. Because we don't have a proper definition of what it is. Today, we have difficulty to tell him what it should be, because we don't know what it is really. So we know it should be organic matter. We know we should have some microorganisms. We know this, we don't know that, but numbers, figures, parameters, and monitoring, we are not really in. Let's say we are at the beginning. We're starting offering an analysis of microbiome, soil microbiome, in very specific situations like baby leaf, where we can, let's say, maybe control very much situation and the risk and the disease in the soil and the organic and the way they farm. That is something that we're not touching much today. The disease monitoring is the same. soil disease monitoring, it's not something that we can evaluate or we can follow very easily. Sorry. As far as the plant is concerned, here we have another element which is part of the plant soil environment. The first part of the plant relates to the soil. So obviously the physical, chemical parameters are extremely important. We have tools, but we don't always have tools to monitor during the period and during the season. We have a measure of photosynthesis pad, etc., etc. We don't have anything about biodiversity, and we could also be looking at the microbiome on the plant. We looked at the soil, but there are also very interesting studies made on the plant microorganisms and the presence of disease. Mac in Trento made some very interesting work a couple of years ago on the relationship between microorganisms on leaves and downy mildew, for example, on grape. Then we need to model that, and we need to make it valuable to farmers in order to have a way to approach the disease. At the same time, we look at programs for biotic stress, for example. They don't believe that they include the resistance of the plant. Say, how do we introduce the fact that the plant or a cultivar or a variety is more resistant to a specific disease? If we look at programs, and we heard some Matteo this morning talk about programs on grape, how do we create programs? How do we know which plant protection product to use in a certain context, if we want to add some natural product with it? Therefore, we need to understand the persistence of a product, the degradation pattern, etc., etc., which today we're only at the beginning of modeling these things, because it's essential to know how a plant protection product will act in order to know what kind of natural product we could use with it or add with it in order to get to the objective of zero residue, for example. And last in this case, the abiotic stress, which, apart from the weather condition that we understand as basic stress to cold and hot, to cold and heat, the interaction with what I call the micro conditions, which is the microclimate in the area where the plant is, which can be a greenhouse, it can be a field, it can be many situations, but there are interactions that we today would need if we want to understand better the stress. We need to integrate the natural resistance of the plant, or at least the genetic resistance of the plant, in order to get the farmer to a proper decision and probably to decide to move a step forward into the direction of using natural product. These are just elements and thoughts which I thought may be interesting to introduce in the modeling, in the DSS, in the precision farming, because a lot of things are moving in that direction. But I think we need to be, again, looking a little bit outside the box at agronomy, because we sort of going back to agronomy. We left it a little bit aside for 30 years, but we need to go back a little bit and integrate in our model some of these elements of agronomy, which I think are extremely important to the farmer if we really want to move in the direction where we know we have to go. It's just a question of how long we want to take to get there. Thank you very much.
Thank you, Vincent, for this nice presentation, and thank you again for joining us and accepting our invitation in this first TERRATECH workshop. So
Thanks
it's
to you.
time for questions. If someone wants to make any question, we have one from Ali Akbar. In case of drought conditions, how can we improve biodiversity and soil health, especially the water holding capacity in a sandy soil?
Okay, the water stress situation is an interesting one, and we've been working on this in the project, European project BREZOF. Basically, we need to look at the interaction between the soil and the plant, and the resistance of the plant. So the soil part, we have done some studies, and we look at studies showing that the integration of organic matter and microorganisms help the plant to resist drought. At the same time, there are some natural elements like betaine and things like this, which applied to the plant will improve the capacity to resist. And that is, I think it's basically the plant will react to the product and create some natural resistance to the water stress. That's the state of the situation that we know today. on let's say in the field, the few elements the few indications that we can give when we are in front of such a situation.
Thank you. Any other questions?
Well, I don't have so much a question, but a comment, Vincent. Thank you very much for your presentation. It was interesting because you mentioned that farmers don't know what is biodiversity, if I understood, and they don't know how to define it. And I think that probably is a problem of scientists, because up to now we didn't find a solution for that. We didn't find the best indicators, and or we have the indicators, but we don't have thresholds for those indicators to show when a soil has a good biodiversity or has a poor biodiversity. And I think this needs to be worked more, and we need to especially we need to demonstrate the relationship between biodiversity and soil functions and soil health. And what you are telling us is that the farmers don't realize yet what is this relationship, if I understood
Exactly.
well.
And the farmer will not decide anything until he's certain, not so much of the result, but he's certain that the economical situation is not going to degrade.
Yes.
So today we have good situations because on some crops, the farmers know they cannot go on the way they're going. They know the basically what they produce at the cost they produce it, it's not viable. So they are forced to change. This is why some people move to organic, for example. In greenhouse, if you are using soil and not soil-less situations, if you're using soil, you better go to organic if you want to make money, because it's so difficult, and it's so the costs are so high that you better go for organic. But again, you need to have solutions to go for organic.
Yes, of course. Yes, because we are seeing this with copper. So we want to replace copper, but the legislation is enforcing us to replace copper, but up to now we don't have solutions for that. That's the big
Exactly.
problem. Yes, thank you so much for your talk. It
Thank
was
you.
very
Thanks.
interesting.
Any other question, comment? Seems I'm not. So again, Vincent, thank you very much for your presentation and for joining us in this workshop. And to all of you, this is the last presentation of today. So with Vincent, we close this first day of this TERRATECH workshop. So thanks for joining us today, and see you tomorrow at 9:30 Central European Time, with the next session that will be devoted to the Erasmus Plus projects related to the agriculture, and then the presentation, the poster session presentation by different students, also on new improvements in agriculture 4.0. So thank you all for coming and for joining us, and see you tomorrow.
Thank you.
Thanks. See you.
Thank you
Bye.
very much.
Bye-bye.
Bye.
Goodbye.
Goodbye. Thank you.